Hello and welcome to our hazards lesson. Today we're going to be looking at volcanoes, and in particular we're going to be looking at the features that make up our two key volcano types. So to begin with, our key takeaway points are to describe the characteristics of our two volcanoes, two main volcanoes, to explain why they are different, and to link to any hazards that might be associated with them. So that'll be our focus for today. So hopefully you have a background of these three things. So first of all, spend a little bit of time just looking at these two images. These are our two key volcano types. Now what we need to do is we need to think about how they look and kind of what characteristics you can physically see from them. I'll give you a little bit of time just to look at them both together. A few things just to bear in mind, and I'll just mark these on. So first of all, you might want to think about the profile. Maybe you want to think about what is coming out. So I'll get rid of this one. So what is coming out of them? And maybe you also want to think about scale, all of these different things. So what I'll do, I'll clear those drawings so we can have a fresh look at these. Now hopefully you've identified a few key things. So what we'll do, we will highlight some of these key features that we can see. So first of all, we can see from this kind of side-on view that one volcano has a very steep profile. I'll just put this down as slope. Okay, so one is much steeper. So of course with our key volcanoes, then we're looking at the other side, and they'll often oppose each other. So we've got a much more gentle profile of this volcano, much more gentle slope. What else can we notice? So it looks like in terms of the size, obviously this is going to be a little bit harder, but in terms of size, it looks like the image on the left is zoomed out a little bit further than the image on the right. So what we could add to this is that they tend to be larger in size, tend to, but not always the case. And for this one over here, they tend to be smaller in size. So we're getting some typical characteristics here. Now, right at the very top, what we might also notice is this. So in terms of linking towards this little picture, which is opposition to the other volcano, this we can actually see, and I'll do it back in black. So this looks like ash or smoke or a cloud coming out. So I'll just put this as an ash cloud first of all. Okay, so there's something that's coming out of that. That's going to be quite key later on. And therefore, if we have a little look in the foreground, our last one, it looks like solid rock. So this one will be quite key. So this is what we actually can call lava flow. It's created our rock on the ground. So these are some of the key characteristics that will differentiate between our two main volcano types. And what we'll go on to do is we'll name them, okay? So these are some key characteristics. We'll delve a little bit further into that in a moment. And I'll clear these diagrams. So these are known as our composite and our shield volcano, respectively. Okay, and inside of them, using some of those ideas we looked at before, we can begin to explain or find out a few more characteristics and begin to explain why they are different. So just to support each one, we can see a different shaped profile. So whereas we said the composite was steeper, just change that font to black. So it was steeper in profile. It looked like it had an ash cloud coming from it. And we could say that they were potentially smaller in size from how that image looked. Now, that's what we had last on that last slide. So if we continue towards the shield side, so we were looking at a gentle profile. We were looking at, looked like a lava flow, so solid rock in the foreground, which seems to be really far away from the actual volcano. And then we've also got, it looks much, much larger in terms of its size. So there we are. So those are the key characteristics. Now, if we look at the diagrams just below each one, respectively, you'll see that they're created in different fashion. So the shield volcano will have the vent where the magma comes from, right at the very top center, and that's the same, exact same as our composite. Okay. Now the composite can also have a few secondary vents that can also erupt and release pressure from the magma chamber. Okay. But there are a few similarities, so let's identify those magma chambers as well. Okay. So in terms of similarities, they both have magma chamber. They both have vents. So that's a key similarity between them. Now, in terms of the differences, as soon as you look at that lava coming out of the volcano, what you might see or notice is that the shield volcano is made up of these different layers of lava. Okay. Now, with our composite, we are made of lava, ash, lava, ash going all the way through. So that links to the ash cloud that's being emitted there. So we'll make a quick note of this. So a composite volcano is made of ash and lava layers. So that is an important point for the composites. In terms of the shield volcanoes, or a shield volcano is made of layers of lava. Okay, so that's a key difference there. So you'll get layers of lava and ash for the composite, and you'll get layers of lava for the shield volcano. So at this point, we can see that there are some different characteristics, okay, in terms of their shape, in terms of how they're built up in certain layers. And now we need to basically put together a reason. Why is this happening? Why are they so different? Okay. And this reasoning will come down to the magma type. Okay, so what I'll do, I'll move these boxes over to the far side, so a little bit further out of the way. So in terms of the magma that creates them, there are two different, well, quite a few different forms, but for our level, we're looking at two key different form types. So you'll have one magma type that is for composite volcanoes, one magma type for shield volcanoes. So if we look at the composite magma first, now this is often known as andesitic magma, and it tends to be very viscous, which is another word for sticky. Which means it is slow moving. Now, it's pretty much the polar opposite, because they have opposing characteristics for our shield volcano. So this is made up of a magma type called basaltic magma. It tends to be less viscous, which means less sticky, and I'll just put down runny, relatively runnier compared to the andesitic magma. So it tends to be more runny and more free-flowing. Let's call it free-flowing. So you have these two polar opposites. One magma type that is very sticky, and one magma type that is not very sticky, very runny. Now this will basically mean that if we have a little look, if we'll have a little look at some of these arrows. So I'll do this next part in red to show the magma flows. So as the magma comes out of the volcano, the free-flowing basaltic magma is really runny, very free-flowing, so it will travel much further along the ground before it starts to cool down. It's free-flowing. It will just pour out of the volcano, and it will travel much further before cooling down. With the andesitic magma, it's much more slow moving, it's more sticky, so therefore it takes a lot of energy to come out of the volcano. It won't travel as far, which gives that steep profile, but also because it's so sticky, the pressure inside the volcano basically build up a lot more, and that means that we'll end up having an ash cloud coming out the top. I'll just draw this as a little circle. So we'll have this ash cloud that comes out the top. So that's as the whole volcano is exploded. The pressure is too much because none of it can be released because the magma is basically blocking the vent. So what we'll do, we'll just make a final annotation, and I'll pop it up here for this. So slow moving magma cools doesn't travel as far. So cools near the vent sometimes it blocks the vent, creating a huge amount of pressure and therefore explosion. So that huge release in pressure will lead to the volcano basically exploding itself apart. So chunks of rock, ash, fine particles will be launched into the air because of that huge amount of pressure being built up. So therefore, with our shield volcano, magma is free flowing. Actually, let's put down running. So it doesn't block the vent. So little pressure builds up. So they tend to have non-violent eruptions. Okay, so that's quite key. So they tend to have non-violent eruptions. Being runny, the magma travels further before cooling down. Which leads to its gentle profile. And you can see how far that lava has traveled from the volcano in the background. So it travels much, much further before cooling down, which gives the volcano its gentle profile. Also, because it's runny, it doesn't block the vent, so it's always going to be a non-explosive volcanic eruption. Whereas the pressure building up in a composite volcano, because the magma isn't moving, will lead to a very explosive, high-intensity eruption where you get ash, rock, and other particles being launched into the air. So, just as we get towards the end, what we'll do is we'll clear those and we'll see if we can associate these different landforms, these different hazards, to these two volcanoes. So we will do shield and we will do composite as black. Okay, so look at those three pictures. What do we assume is going to be the key hazard from both of those? So to begin with, we'll start with shield. So shield, we know we're going to have runny, free-flowing magma. So it's got to be this picture here. With our composite volcano, it's built up of layers of ash and lava. It's very explosive, very powerful, and will often lead to these grey eruptions. So we'll have ash clouds and pyroclastic flows. Okay, so these are often known as hazards of a grey eruption. Therefore, a composite, which creates the layer of ash and lava. And therefore, on the other side, got lava, which is the hazard of a red eruption. tends to be shield, and this creates the layers of lava because it's non-explosive. There's no ash being thrown or launched into the air. So let's look back at our takeaways before the end. So we wanted to be able to describe the characteristics of the two volcano types. We've got shield has a gentle profile, but is built up of layers of lava. Composite is the opposite, steep profile, but is built up from ash and lava. Why are they different? So shield has runny magma, so less pressure builds up. Composite has sticky magma, so more pressure builds up, creating those ash clouds and so on. And then the final bit to link hazards that might be associated with them. So shield has runny lava flows, and composite has ash clouds and what we call pyroclastic flows, ash that comes through on a grey eruption. So thank you very much for listening, and I'll see you soon.